Hi, I'm Jeff Teeter. I'm a Cisco systems engineer with the America's Partner Organization, and today we're going to be going over network programmability. Specifically, we're going to take a look at a project I call Darth Rasp. A little bit of fun, but basically the purpose behind it is to show the amount of power that you can get with network programmability running from just, in this case, a simple Raspberry Pi, which is a kind of a stripped down Linux server that's attached here on Darth Vader. So the goal is pretty straightforward. We're just going to show network programmability using open source software, and in this case we're going to be using Cisco's Open SDN controller. So the mission or goal, what we're going to be trying to do is we're going to try to isolate network resources, specifically servers, for the purpose of disaster recovery exercises, and then after the tests or exercises are done, be able to move those servers back into production so that they're not out of production for a long period of time. The business driver is just that the fact that many businesses today, especially in healthcare and financial institutions, are still using static IP addresses. Specifically, you'll see it a lot when applications need to interface with other applications. A lot of times they use interface engines to transmit that data and reformat that data. And those applications are sending all of that data via static IP addresses. And what that specifically means is when you are doing a disaster recovery exercise, since you have a production domain and a disaster recovery exercise domain that are using the same IP addresses, they need to be totally isolated so that there's no corruption of the production database with test information. So really this is just an extension of some early work I did back in 2011 on what I called rapid adjustable networking, where I basically was able to exploit HSRP to isolate hundreds of servers within a few seconds, be able to perform disaster recovery exercises using those app and web servers, and then after the DRE tests were done, be able to move those hundreds of servers back into production within just a minute or so. The rapid adjustable networking process works very well. The really only downfall is that you have to pretty well pre-plan how many servers you want to be able to move over to your disaster recovery exercise domain. So for example, if you have a new application going in, you have, let's say, 10 web servers and 10 app servers, you need to go ahead and define before the servers are actually put on the network, how many of those do you want to be able to float between the production and the disaster recovery environment. So some of the resources we're going to be using today, Linux, OpenFlow, Open Daylight. We talked about the Raspberry Pi. All of this is going to be programmed in Python. And I just also threw up Cisco DevNet because it's a great resource to go out and get some ideas about how you can use open source software and some of Cisco's products to solve real business problems. So the lab today that we're going to be doing is basically we're going to be using Cisco 3850, nothing special about this, using Raspberry Pis, which are stripped down Linux servers, 12 of them that are attached via Cat5, Cat6 to 3850. We have a little Python program running on Darth Vader here that is able to communicate to the 3850 and is also able to communicate with the Open SDN controller. And the purpose of this program is basically to isolate servers for the purpose of disaster recovery exercises and then be able to move them back. So the lab is pretty much laid out like this. The Python program, the SDN ran that I wrote, is running on this Raspberry Pi that's attached to Darth Vader. We have Open Daylight running just on VM Workstation 10, just on a regular desktop. We have a 3850, nothing special about this, just your standard 3850 that's probably running out in hundreds and hundreds of enterprises out there. And then for the Linux servers, we're using Raspberry Pis. So let's go ahead and take a look at the lab real quick. Okay, and as you can see, we have a bunch of displays here. We have a user and a test user on the sides of the first row, and then in the middle we have 4 web servers, 4 app servers, and a database, and a disaster recovery database. And what I'm going to go ahead and do, let me transition over here, is I'm going to first go ahead and restart all the Raspberry Pis to make sure that we have full connectivity. Okay, so you should see, go ahead and transition to a full screen here. You should see the Raspberry Pi start to reboot, and they'll come back up here, just making sure that everything's connected to the network before we start our test. And that should take just a minute or so, and you can see they're starting to reboot right now. And it looks like they're about up. Should take just another minute or so. And it looks like they're starting to pop back up here. Okay. Okay, and now they're all back up. I'm going to go ahead and transition over here so you can see what I'm going to do. The first thing I'm going to do is I am going to send a command to basically run a Python program that I have running on all, or I should say that's stored on all these Raspberry Pis, and it's going to turn each of these monitors, these Raspberry Pis, into a network monitor. So let me go ahead and issue a command here to start it. The name of the program is teeterping.py, and it'll ask me for a password. I'll go ahead and do that. Go ahead and make it bigger so you can see it. So now basically it's started the program. It's going to throw a Raspberry Pi symbol up, and then it'll switch over to Cisco, the Cisco symbol, in just a second. It looks like all of them are working correctly. And then what's going to happen after just a few seconds is they're going to start a ping to find out where they are in the network, if they're on production or disaster recovery, and I'll show you over here. So basically what's happening is each of these Raspberry Pis are pinging different IP addresses to determine where it is in the network. And this is happening on all 12 Raspberry Pis. As I'm clicking through here, you can see that. Go ahead and transition back over here. So you can see, and they're displaying basically what they are and kind of where they are in the network. So we have a regular production user over here. We have web servers 1, 2, 3, and 4. This is a disaster recovery user, and you can see he's white and very different from the green. Then you have the app servers 1, 2, 3, and 4, which are all green, and database is green. So all green is meaning production. When it's white, it's in disaster recovery mode. If it can't communicate, it's missing all pings, then it'll go ahead and turn red, and you'll be able to see that. So next, let's go ahead and launch the SDN RAN application, and I'll go ahead and bring that up. Have a PuTTY connection. Let's see here. There you go. Let me go ahead and launch this. Okay, now the application is starting. Take just a second for it, and then it's going to ask us some various choices. So it allows us to display the number or the servers that are isolated, which interfaces are isolated. We can create a list of servers that we want to isolate in the future. We can go ahead and set up the DRE environment, which basically connects the 3850 to the Open Daylight controller and connects the DR database and the DR test user over into that environment. Number 5 here actually activates the test, 6 deactivates it, and 7 completely clears everything. It basically disconnects the 3850 from the Open SDN controller. So let me go ahead and shrink this down. Let me transition over here. So it allows you to see it. What we're first going to do is we're going to go ahead and set up the DRE environment. So we just hit number 4 and hit enter. And what this is going to do is it's connecting the 3850 to the OpenSDN controller. And it will also go ahead and move the DR database and the DR test user into that environment. And what you can see here, which is on the screen, basically it also, just to verify it, the application does a RESTconf connection to the Open Daylight controller and finds out specifically what's connected, what flows, what IP addresses and interfaces and all that information. So we can see here that we have a couple hosts that are that have been moved over, and if you look at what's happening on the screen, you can see now that the DR database and DR test user is now red. It is in that disaster recovery mode, but the reason that it's red is because there's no app and web server that's been moved over to the disaster recovery area. So that is the next thing that we're going to do. We can also list and see which interfaces are connected. And right now we have 2 interfaces, which are the interfaces connecting to the DR database and the DR test user. So now we're going to go ahead and list a couple app servers and web servers that we want to go ahead and move over when we activate this. So we just go ahead and add a switch interface. So the interfaces that I'm going to add are interface 7, interface 6, interface 9, and let's see, interface 3. Now I'm just doing these, one at a time. You could actually write an application to just import a list, or you could have it where it just takes the server's name, use some type of DNS query. But basically right now we have the DR servers that are already actually activated. We have 2 web servers and 2 app servers. So that's what's on the list to go ahead and get activated. Now in a real disaster recovery exercise, this is exactly what you would do. You'd want a whole list, maybe you have 100 servers, maybe 1,000 servers. You have this on a list, and then when you're ready to actually run the disaster recovery exercise, then you execute the script. It'll move all those servers, you perform the test, and then you can deactivate and move it back. So let's go ahead and do that. What we're going to go ahead and do is we're going to ask it to activate the disaster recovery exercise. So we're going to click number 5. Okay, and it is activated. As you can see, we have lights also that have been turned on, and that's actually also being done by the Raspberry Pi. If you can see, we also have, let's see, we also have an alert. I got a text message that the DRE test has been activated. The Raspberry Pi sends out RF signals to the lights to turn those on, and besides the lights and the text message, we can also see it has also sent out an email that a DRE test is activated and that a DRE test is underway. And all of this is just written into the Python code on the SDN RAN application. So as you can see also, the servers have, let me go ahead and transition to a larger view for you. The app servers and web servers are in the process of getting switched over. We're waiting for the last, I think, web server to actually get transitioned over, and it is. And so these are now performing a disaster recovery exercise. The test DRE user can hit the web servers and app servers, and the database servers also getting connectivity to the app servers. So all this is occurring, and the DRE test is going well. So when we're ready to go ahead and move these servers back, let me go ahead and transition so you can see it. Let's get rid of that, and then also on here, let me go ahead and delete this message. These tend to pile up pretty quick. Let me go ahead and deactivate the test. So we do that by just clicking number 6. And as you can see, it has been deactivated. The lights have been turned off. Momentarily, we'll be getting alerts via email and text also. So we got a text message that the DRE test has been deactivated. And go ahead and check our email. And we have an email that the DRE test has been deactivated. And we can also display in host tracker to see what's left. And we still have not as much, but we do have a couple devices that are connected, and this is the DRE database and user, and also obviously the 3850 is still connected to the OpenSDN controller. So to go ahead and basically clear all that, we just hit number 7 here. And what will happen is it'll actually move the database, the DR database and the DR test user back over into the production area, and we can take a look and make sure that the 3850 is no longer attached by just displaying a host tracker, which again is just doing a RESTconf call to the Open Daylight controller to seeing what's there. And as you can see, there's nothing attached to the Open Daylight controller anymore. So that's all that I really wanted to show you. Just a couple call-outs I did want to make. For the people that took the Coursera class and you went through that, and there were some questions about, how could you take and apply this information that you learned in the Coursera Python class through Rice University. On the network monitors, the entire application is written in Pygame. So this is something that's very similar to some of the different activities that we did through Rice University through the Coursera class. So I just wanted to throw that out there. And I will be following up on another video to actually go through the Python scripts, both on the Raspberry Pis that were acting as network monitors, and then also on Darth Rasp, going through that and showing how he's able to not only isolate the servers, but be able to communicate to the lights, to turn them on, to send text messages, to send emails, and basically how everything is kind of put together. So I appreciate your time, and look forward to other videos in the series. Thank you.